All right, today's lesson is on factoring completely. Um, if you look at the second page of your notes packet, the back of the pink sheet of paper, you will see that there is a chart, a flow chart that tells you all the steps that you need to do in order to factor completely. So I'll be referring back to that flow chart a lot. But if you look at today's notes, what you need to do is you need to make sure that you ask these questions whenever you're factoring. This is kind of like a condensed version of that flowchart. So first of all, you're going to ask yourself, is there GCF? Then you're going to look and see if it looks like a difference of perfect squares. Please be careful that if it's a sum of perfect squares, remember you cannot factor it. Then you're going to see if you can factor a trinomial by grouping or trial and error. And lastly, this is really important, you have to make sure your final answer is completely factored. Sometimes it looks like you got it completely factored, especially because you went through this long list right here. But sometimes there's some hidden problems that you can factor even further. So just be extra careful to make sure that you really truly factored it completely. I just want to make a quick note that this flowchart that's on this page right here is very similar to the same process that we have on your paper in front of you. And we're going to talk about this more in depth when we do an actual example together. All right, so let's get right to it. The first question you're always going to ask yourself is there a GCF? So what you need to do is you need to look right here at your two terms that you have and look and see if there's anything in common with either of these terms. So you've got 50x squared minus 242y to the fourth. I'm going to look at 50, I'm going to look at 242. I know that there's a common factor of 2, so I'm going to factor out a 2. I'm going to look and see if there's anything in common with my variables. This is an x squared, this is a y to the fourth, so there's nothing in common, which means that 2 is my greatest common factor. Once I factor that out, I'm going to look and see what I get left over. So I end up getting 25 x to the second power minus 121 y to the fourth power. Okay, so then I'm going to see what the next question is asking. Does it look like a difference of perfect squares? So if I were to look at it, I have two perfect squares right here. 25x squared is a perfect square. 121y to the fourth is also a perfect square. It's a binomial, which means it could possibly be a difference of perfect squares, and it's a difference because there's a subtraction sign, so I know for a fact that it is. So what I'm going to do is I'm going to take this expression right here, and I'm going to factor it. So remember, when you factor a difference of perfect squares, you've got your two binomials being multiplied together. The square root of 25x squared right here is 5x, so I put 5x right here, and 5x right here. The square root of 121y to the fourth is 11y squared, and remember, in order for the carets to cancel out, this has to be a positive and this has to be a negative. Remember, it doesn't matter what order as long as they are different signs. Now, do not forget to look and see, or to bring down this GCF right here. You can't ignore it. So this GCF still goes in front right here. Okay, so now let's look at the next question. Can I factor a trinomial by grouping or trial and error? I have three factors now. I have my 2, which is a monomial, which is not factorable. I have this binomial right here, so it's obviously not going to be able to be factored by trial and error or grouping. And this one, same thing, it's not factorable by trial and error or grouping. So then I look and see what the last question says. Is my final answer completely factored? This is the most crucial question to make sure that I have a final answer. So if I look right here, the first term that I have is a monomial, so there's no way I can factor this any further. This second term right here, there's nothing in common. It's not a difference of perfect squares, and it's not a trinomial, so it's not factorable any further. Same thing with this, not a difference of perfect squares, and it's not a trinomial, so that won't work either. So that means that this is my final answer. My problem has been completely factored. Okay, we're going to look at question number 2. If you could have that flow chart on the back of the first page of your notes packet to follow along, I'm going to show you how to use the flow chart for question number 2. Again, it's very similar to the questions that you see on the top of your paper here, but I want to show you how the flow chart works as well. So let's look at the flowchart. We're going to compare back and forth. The first thing you're going to do, since we're talking about factoring polynomials, is you're going to see if you can factor out any GCF. So let's look and see right here. I've got c cubed plus 2c squared minus 35c. The first thing I'm going to look at is my coefficients. I have coefficients of 1, 2, and negative 35, which means that the greatest common factor of those numbers is just 1, so it's not really important, so I'm not going to write down 1. But if you notice, there is a c in common with all 3 of these terms, so I'm going to look for the lowest exponent. If I've got c cubed, c squared, and c to the first, that means that c to the first is my GCF. So I'm going to factor out my GCF and see what ends up happening. So when I factor it out, c cubed divided by c gives me c squared. 2c squared divided by c gives me 2c. And negative 35c divided by c gives me negative 35. Remember, c divided by c is 1. I don't need to write that down. So that is my first step. Now, if you look back at the flowchart again, the next thing I'm going to look and see is if it is a monomial, a binomial, a trinomial, or a polynomial with 4 or more terms. In this example right here, this is a trinomial. So I'm going to go to the trinomial section of my flowchart. So on the trinomial section, I'm going to look and see, is it a perfect square trinomial? Remember, that's what we learned last class, where it's in the format a squared plus 2ab plus b squared. Or I'm going to see if it's just a general trinomial. It is not in the format a squared plus 2ab plus b squared, so that means that it has to be a generic trinomial. So I'm going to go this route right here. And I've got 2 choices. I could either factor by grouping, which is what this flowchart here says, or I could use trial and error. It's completely up to you. Remember, because this has a leading coefficient of 1, it makes things a lot easier. So I'm going to actually use trial and error for this one. So what I'm going to do is I'm going to see what what terms I can place in front right here that will multiply out to give me c squared. Again, because it's a leading coefficient of 1, it's nice and easy. I end up getting c here and c here. Okay. Then I'm going to look for some factors of 35. So let's make a chart for factors of 35. So my choices are 1 and 35, 2 is not an option, 3 is not an option, 4 is not an option, 5 is an option, 5 and 7. 6 is not an option, 7 is an option, but it's already there, so I've exhausted all possibilities. Now, I'm looking for 2 as my B term, so that helps me narrow down what I want. I'll use 5 and 7 because I can get a 2 from those 2 numbers. The only reason why I can go straight to 2 is because this c and this c have coefficients of 1. So let's just do our carets really quickly just to double check to make sure that this is right. This gives me 5c, this gives me 7c. If this is a negative 5c and this is a positive 7c, then I know for a fact that those are my values that will work, which means that this is a positive 7 and this is a negative 5. Do not forget the most important piece is that you need to bring this c down right here. Don't forget your GCF, okay? Okay, now the only issue that I have with this flowchart is that it gives you the impression that once you get to this point, you are definitely done. And although in most cases you are usually going to be done, it doesn't necessarily mean that you are definitely done. So please make sure that you go through and you ask yourself that really important final question. Is my answer completely factored? So if I look at this right here, this is a monomial. So if I look at my flowchart, monomials can't be factored any further, so I don't have to worry about that. Then I'm going to look at my second factor, which is c minus 5 right here, and it's a binomial. So I'm going to look at my chart and see what it says about binomials. It either is 2 perfect squares or 2 perfect cubes, but we're not worrying about perfect cubes right now. You'll learn about that in the future. So I'm going to look and see, are there 2 perfect squares right here? So if I look, I do not have two perfect squares right here. I don't even have one, regardless, but I need to have two. So that can't be factored any further. And this right here, same thing, it's a binomial, but it's not two perfect squares, making this my final answer. All right, question number 3. The first thing I'm going to do always is ask myself, is there a GCF? So if you look at your example in question number 3, you've got coefficients of 9, 78, and 27. They are all divisible by 3, which means that I definitely will have a GCF of at least 3, if it lets me write it. And then I'm going to look at my variables. I've got x squared, x, and there's no x here. And remember, the C in GCF stands for common. There's no x in common, so I can't include an x in my GCF. So I'm going to divide each term by 3, and I will end up getting 3x squared minus 26x minus 9. Let's look and see what the second question asks. Does it look like a difference of perfect squares? Now don't forget, in order for it to be a difference of perfect squares, it has to be a binomial. So I'm going to look and see what's inside of my parentheses here. It is not a difference of, or excuse me, it's not a binomial, which means it can't be a difference of perfect squares. So let's go to the third question. Can I factor a trinomial by grouping or trial and error? Because it's a trinomial, let's look and see if I really have a trinomial in my example. I do have a trinomial here, which means that I can factor this possibly by grouping or trial and error. It's not always necessarily factorable, but it does look like it might be a little bit promising. So let's try it and see what happens. Now, because of this leading coefficient not being 1, I'm going to try grouping just to see what's going to happen. I think it's going to make my life a little bit easier if I use grouping in this example. So what I'm going to do is I'm going to take my A value, which is 3, my C value, which is -9, and I'm going to multiply those two numbers together. So 3 multiplied by -9 gives me -27. So then I'm going to look at all possible factors of 27. So my choices are 1 and 27. 2 doesn't work, 3 works, 3 and 9. 4 doesn't work, 5 doesn't work, 6 doesn't work, 7, 8, neither of those work. 9 works, but it's already in my chart, so I have all possibilities. So this right here are my choices, 1 and 27 or 3 and 9. Now remember, in order to figure out which one of these factors is the proper set of factors, I'm going to look at what the B value is. The B value is -26. So I'm going to look and see which one of these sets of factors can give me a -26. And that would be 1 and 27. So what I'm going to do is I'm going to rewrite this so that it looks like 4 terms in my polynomial instead of 3 terms. So it'll be 3x squared minus 27x plus positive x minus 9. Remember, it doesn't matter what order you put these two into as long as the 27 is negative and the x is positive. Don't forget the really key piece of bringing this 3 down right here. I need to take my 4 terms and I need to break it up into groups of 2. So I'm going to pair the 3x squared minus the 27x together. And then I'm also going to pair the x minus 9 together. But remember, this whole thing is being multiplied by this 3 right here. So I'm going to put large brackets around this expression and remember to bring my 3 down. Then I'm going to factor out a GCF in each set of values right here. So 3x squared minus 27x has a 3x in common, so I'm going to factor out my 3x. And I end up getting x minus 9. And then x minus 9 really only have a 1 in common, so I'm going to factor out a 1. And then I get x minus 9 right here. Don't forget your large set of brackets with your GCF out in front. Lastly, I'm going to go through and see is there, or I'm going to factor out what's in common with these terms right here. So what's in common is that there's an x minus 9. So I'm going to take the x minus 9 out. And then I have a 3x, this 3x right here, and a 1 left over. That's what I ended up getting when I factored what was inside of the parentheses here. But again, don't forget that you have to bring this 3 down, your GCF of 3, so this right here has a 3 here. Don't forget the last important question. Is my final answer, completely factored? So if I look at my final answer right here, is there anything else that I can do with this 3? There isn't, because it's a monomial. Then I would look right here and see if there's anything else I can do with this x minus 9. Again, I can't do anything with it because although it's a binomial, it is not a difference of perfect squares. Careful, it looks very similar to what a difference of perfect squares would look like, but this x is not a perfect square. Same thing here. I would look at this, see if there's anything that I can factor out of it. It is a binomial that is not a difference of perfect squares, so this is as far as I can go, which means that this is my final answer. All right, last question, number 4. Please try this one on your own. Press pause, and then when you're done, go ahead and check your answer with mine. I'm going to go through it a little bit quicker, just to make sure you get the chance to try this on your own. All right, so the first question I'm going to ask myself is there a GCF? There is a GCF. It is x squared, so I'm going to factor out an x squared. And when I factor that out, I get y squared plus 7y minus 60. Now, I'm going to see if what's inside of here is a difference of perfect squares. Because it's a trinomial, it is not. So I'm going to go into factoring trinomials. I'm going to bring my x squared down, and I'm going to set this up to factor my trinomial. Now I know that I can only put y here and y here because, again, the leading coefficient of this y squared is 1. And then I'm going to look for factors that multiply out to give me negative 60 but add up to give me positive 7. So those factors are 12 and 5. I know it's a positive 12 and a negative 5 because 12 multiplied by negative 5 is negative 60 and 12 plus negative 5 is 7. Lastly, I need to make sure, is there anything else I can factor inside of here? X squared is a monomial, not factorable. This is a binomial that's not a difference of perfect squares. Same thing with this, it's a binomial that's not a difference of perfect squares. So I cannot factor this any further, which means this is my final answer. And that is how you factor completely.